Is it class? Good. Is that indeterminate? Yes. Okay. So now, when you have one of the three indeterminate forms involving an exponent, we're not going to find the limit of this original expression right away, right? We're going to find the limit of something else, the ln of it. Okay? We're going to find the limit of the natural log of x to the 1 over x, and we're going to get that limit. And then the limit of the original will equal e to that limit. So we're going to let L, oh, I'm not calibrated, I don't know if I can, but we're going to let L equal the limit, bug me, oh, I can't, what do you have to do? Of the natural log of x to the 1 over x. Now, why would we bother doing that when we got indeterminate forms involving exponents? Why would we bother putting an ln in there? It brings the exponent down. It's no longer up there. That's why we do it. I'm going to calibrate fast. Think about that for a second. Okay, so let's see what we have. So now we'll be taking the limit as x approaches infinity of what? 1 over x. Good. Times the ln of x. You know where this is going. All right, what do we get? 0 times infinity. Oh, good. Oh, or is that another indeterminate form? It's another one, but what do we do now? Yes, we rewrite it as a quotient. Now, which one do you want to keep in the numerator? All right, you even knew what I was going to ask before I even asked. So what we do for that indeterminate type, we take the limit, we keep one of the factors, and we divide by the reciprocal of the other. X. Oh, that's not bad. So now what indeterminate form do we have? That's infinity over infinity. Oh, now we've got that indeterminate form. What do we do? L'Hopital. So now this limit is equal to the limit as x approaches infinity of 1 over x over 1, but I don't have to write 1 over x. I don't. So it's 0. Now, am I done? Do I just move on? I write that and circle it? No. Well, guys, remember, this is not what we were asked for. We were asked for the limit of x to the 1 over x. We found the limit of the natural log. That's the exponent, right? So the limit of, so therefore, you don't have to do that. The limit of x to the 1 over x as x approaches infinity equals e to the 0, which is equal to 1. Okay, because we found what was going on with the exponent on e. When you take the natural log of anything, okay, when you take the natural log of a number, of any number, okay, you're figuring out what exponent you have to raise e to get that number, okay? So we're not finding out the number, we're figuring out the exponent when you take the natural log. So you have to remember with these indeterminate types involving an exponent, once you get L, your answer to your original problem is e to the L. Yes, that's your exponent on e, and then you got to put it together. Isn't that fun? The limit of the ln of x to the 1 over x we got 0 for, because remember we started with that. Right, that's what's going on with the ln of it. That's 0. So that means the limit of x to the 1 over x, without the ln is. Wasn't that the original? Yeah. See, I wanted the limit of this, all right? But I found the limit of the ln of it. This is the best type of fun. And it usually does happen. You get an indeterminate form involving an exponent. You do the limit of the ln, and then usually it's the 0 times infinity type. You rewrite it, and it's 0 over 0, infinity over infinity, and then you apply L'Hopital. And then after all that, you have to remember the answer to the original is e to that limit. But this is like the natural flow, so it's not like it'd be really weird every time. Let's try another one. I bet we should. Remember this one. This one must be important. This is 1 to the infinity. Hey, are you writing this down? Hey, are you writing? See, you're writing. Just turn. Yeah? This one? Yeah, when you plug in 0, this is in the form 1 to the infinity. Is that one of those indeterminate types? Yeah. So now we know we're going to have to do, we're going to have to find the limit of the ln of that. So I'm going to say let L, hopefully I'll remember that, equal to the limit as x approaches 0 of the ln of 1 of 1 plus x is 1 over x. And then what's our next step after we bring the exponent down? So equals the limit as x approaches 0 of 1 over x times the ln of 1 plus x. Now what is that? Let's think about what this would be. 1 over 0, infinity, times 0. The ln of 1 is 0. What is that type? So now we're going to rewrite it as a quotient. Yeah. This is equal to the limit. You'll leave the ln on. No, let's not do the other one. So it's going to be over x. Divide by the reciprocal of the other factor. So this time it's 0 over 0. Okay. Now that we have 0 over 0, that's our third indeterminate form so far. We still don't know what this is, but now we can do something about it. L'Hopital. What's the derivative of the numerator? 1 over 1 plus x. What's the derivative of the denominator? 1. So I'm not even going to write it. Or should I write it? It's better if I write it. I'll just write it really faintly. I can't write the number. Alright, it's over 1. Now, what do we get? 1 over 1, so we get 1. But that's not the answer to our question. The answer, right. So the limit of our original problem, 1 plus x, correct, equals e to the first, which is just e. This is one of the definitions for the number e. It's a good one to know. Oh, how do you get rid of this number? Here it is. See that one? You like it? Yes, it's e. Yep. You'll see this like a lot of places. This is that's a famous limit. You don't have to memorize it because you can always figure it out, right? I did, probably. Let me see. Wait. I'm sorry. Yeah. It's either infinity or negative infinity, depends which side of 0 you're on. But when you're looking to see what indeterminate type you have, just think infinity. Yeah. Yes. It's undefined, but think about like the graph. You have it's shooting up to either infinity or negative infinity. So it's perfect. Do you want to do this? You don't? No, I just thought you guys would be interested. Remember Yeah. All right. No. No, it's just an interesting, I thought the kids want to know where perk comes from. All right. So to remind me though, so is this is the end of this? Yeah. No, no one would have. Okay, so let me go to the other one then. Some, yeah, we're on today's notes. Here we go. Look at this. I got pockets, not talking. It's horrible. So annoying. Okay, kids, you're being annoying. All right. Because we're gonna kind of hit the same thing right here. All right. What are the three indeterminate forms involving exponents? Okay. Let me just make this larger. Okay. So 1 to the infinity, infinity to the 0, 0 to the 0. Wait a minute. Do I have the wrong 0 to the infinity? Oh, bye. Happy birthday. At center H. Ooh. Yeah. Because we had talked about. Yeah. Okay, guys. Okay, so we know that it wasn't Leo who's doing all the talking. Okay, so we have a limit. Okay, so we have the three indeterminate forms. What? Okay, infinity minus infinity. Oh wait, there weren't just. Oh, I just said the other. I thought I said three because there's four. So 0 times infinity or vice versa. I don't want to write it. 0 over 0. And this is it, guys. These are all the indeterminate forms, so you don't have to worry. I'm not going to throw anything else in. I know. Like, this is like yesterday's summary. That's why I'm having it here. So when you want to find the limit of an indeterminate form that has an exponent involved, can you think about the steps you have to do? Right, Ryan, you tell me. Okay, right. Uh huh. Okay, right. You keep going. I don't know why I said three. You could make it as many steps as you want to just start that that little story. You can take more, but basically you're gonna have to take the ln of the function. You're gonna have to find L, the limit of the ln of that function. That might take several different forms, determined forms to get to it. But at the end, you got to remember that the answer to the original problem is e to that limit. Can you see this in the back? Yeah, look at it. I should actually ask you if you can see, because you're like the farthest. You pretty much got as far away from me as possible, didn't you? Interesting. That would completely choose. Well, if anyone can think of a better way to arrange the seats, I'm open to suggestions. Well, that's it. I think we should move them up. You. Or does it you? I'll have to go check it out. See if I like it. Maybe I will. Maybe I will. I'd have a scepter. I'd have everything. Okay. I think we know this because we did this already, right? This one. Okay. What do we do for this last one here? Yeah. Or I should say, as a single factor. You did. You did. Yes. Combine them into a single fraction. I wrote rewrite as a single fraction. The word combine would have been better. I'm erasing mine. Combine. Yep. No. No. Well, now I want to go over the homework that you did try. Two problems. What numbers? Thank you. The second one, you keep one factor and you divide by, you rewrite it as a quotient, okay? So keeping one factor in the numerator and putting a reciprocal of the other factor in the denominator. So you have to rewrite it as a quotient would be the short version of that. And this one is just apply L'Hopital's. You already know your answers are wrong? Oh. Oh, now you know. So wait, was it 16? Oh. Okay, let me see if I have I have it somewhere else, but I don't look at it. Alright. Yeah, no, because I don't have it on this one. Oh, 14, 15. Oh, so don't even look at that. This is not what you tried? Oh, yeah, this one we did. Okay, good. Yeah. Now I'm going to go back because I got to get 14 and 15. Yeah, yesterday, so that's this one. No, it isn't. That's on the one. Alright, try this one. Alright. This is the one I had to speed through it. You guys were staring at it. You got the answer. Yeah, there we go. Okay. Alright. 14, 0. Okay, so did you first combine these by any common denominator and rewrite it? Okay. Good. So, guys, you should be checking. Did you combine it right? Okay, then you have the right form. It's going to be 0 over 0, so you can apply L'Hopital's. Once you apply L'Hopital's once, you're good. Are we alright with this? 15, the answer is negative a half. Sure wasn't 15 you were looking at? You got that right? No way! What? Anyone else get that right? Alright, let's find out where we had a problem. Did you get the right common denominator? Check that. Because it was infinity minus infinity, so you had to get a common denominator. Then we just what happened after that? Well, it was still 0 over 0, so you could apply L'Hopital's. You had to use the product rule down here to clean it up. Does anyone want me to show you that part? This was 0 over 0. Too much talking. It's too hard with too many people. This is 0 over 0. So you apply L'Hopital's. To take the derivative of the denominator, you have to use the product rule. Okay? It's first times derivative of the second plus the second times derivative first. Okay? So it's just x e to the x plus e to the x minus 1, the derivative of the denominator. The derivative of the numerator is just 1 minus e to the x. So now we check it out. We plug the 0 in. Oh my gosh, it's still 0 over 0. Do it again. Take the derivative of the numerator, negative e to the x. Or the denominator, well, at least you already know what the derivative of... Oh, no, you don't. You have to do it all over. You have to use a little product rule. Take the derivative of the x e to the x. And when you do that, you'll get this. And then take the derivative of e to the x. That's just e to the x, right? Derivative of e to the x. And then you try it again. You plug in the 0, and then you're done. You get the negative half. Got it? So now, I'm thinking, so I really don't know what I should assign to you tonight. Should I assign you just the ones I was originally going to assign you, the rest of that other sheet, or should I do what I was going to do? What up? Oh, you have the take-home test. All right, so I'm going to be super, super nice. Why don't we just work on the homework that we were going to do last night, and then I'll save the other ones for Monday, the ones in this packet. So what was supposed to be last night that we didn't get to? 16 through 22. Let's pick out some of the worst ones in there. Like, take a look and let's see if there's anything in there that we would want to avoid. Sure. Yeah. Oh, yeah. Like when we were doing AP review and I'd have it. You like that? Nice. Okay, let's do 22. I can't. All right. We can do that. Just remind me if I forget. We're going to do 22 now. Oh, wait. Is this the one with the graph that gets crazy? Okay, good. Let me see. That's kind of fun. Guys, before we do 22, though, is there like a more basic one? Because that's not one you're going to. Yeah. Oh, what's there? 18? What? 18 is good? With an X to the sign X? So we're going to try 18. Because I want to make sure you guys got this. And actually, you guys try this one first, without me. X, the sign X. Like 0. Are you just looking at the graph to get the answer? Okay. Try. We gotta hurry up. Okay, here we go. So we're gonna let L equal, because this was a 0 to a 0. So we're gonna let L equal the limit as x approaches 0 of the natural log. I should have just put the exponent down right away. We bring down the exponent, so we have the limit as x approaches 0 of sine x times the ln of x. And what form is that? 0 times infinity, and it's negative infinity, which is 0. So now, people that were successful, which would you keep on top? The ln? Yeah, I would keep the ln on top too. I think the other way just gets too ugly. So we want the limit as x approaches 0. The ln of x 1 over sine x, which is secant. No, you didn't have to. But then when you take the, because right now we're going to have infinity over infinity. So I think it's. You wanted me to keep it 1 over sine, not make it cosecant? Okay. As x approaches 0. So now we've got what type? Infinity over infinity. So now we're going to apply L'Hopital. Okay. My goodness, you just took the quiz. Tan x. Too bad. Now, here's the thing. I was thinking that might be better. Instead of having complex fractions, maybe we could rewrite this as just normal fraction. That's not so crazy. So if you were just going to bring it up, it would be with the negative cosecant x cotan x would be down here. Okay? But then, just write that. Cosecant x cotan x. Oh, wait a minute. Yeah, that is really ugly. But I was thinking we can now change it up a little bit. I don't like it all down here. Wait a minute. No, we're not done. Try to work on it. See if the homework is just your take home. I think it's yeah, just your take home, because what I'll do is I'll do the review that I was going to give you for homework on Monday. Okay. Oh, I was thinking I could put it. Stuff.